So hello everyone, welcome back to my channel. In the last video we discussed regarding the traversals. In the last video we discussed level order traversal, and in this video we'll discuss some more important operations on the tree, that is counting the number of nodes in a tree and counting the sum of all the values of all nodes in a tree, and then counting the height of a tree. So first we'll start with calculating. Count number of nodes in a tree. So it is simple. Like for example, if I make a tree like this, so it is simple. We can run any traversal that we have studied before, and simply just visiting each node once will get the count of number of nodes in a tree. So you may try it once by pausing this video by yourself using any of the 4 traversals which I told just now. Okay, so now I'll code this this function for counting the number of nodes. So the return type would be int, because I'll be returning the count of nodes. Okay, so I'll make the function name count node, and the parameter that it will take would be the root, that is node type. It will take of the binary tree, and the base case, if the root would be null, so like there would be nothing, no node, so simply I'll return 0 in this case. If root equals to null, equal null, then I'll return 0. In this case. Okay, now like for this particular node, what to do? First break it down. Okay, break it down into simple. Like if I'll say count the total number of nodes, it sounds like a very heavy task. Okay, break it down in what sense? Like first count the number of node for this particular node, count the number of nodes to its left. Okay, and secondly count the number of nodes to its right. Okay, and add +1 for what? For this particular node. Similarly do it for this, number of nodes to its left, number of nodes to its right, +1. Similarly for this and all other. So the bigger problem gets easier by doing this. So I'll take 2 variables, int left. I'll call this function count node and give the parameter root.left. For a particular node, give count of nodes to its left, and similarly int right. This variable will give me the count of nodes to the right of any node. Okay, so what would I return? I'll return number of nodes to its left, okay, plus number of nodes to its right, and +1 for itself. Okay, so that's how. This is a very easy recursion code for counting the number of nodes in a tree. As I told, I'll again do a dry run for this. Okay, so for this the code will come over here. Is it null? No, it is not. Count left of this. Okay, so left. Now the recursion call gets come over here. It will come again over here to its left. Okay, to its left again here. Is it null? No. Then to its left. Now pointer comes over here. Now the root is null. Okay, return 0. Here comes 0. Okay, to its right, pointer come over here. It is null, so return 0. Now left is null, right is null. Sorry, I'll repeat my camera lens. I hope it is visible now. So what I was saying, that I made for a dry run I made a demo tree. Okay, so for the recursion call, first it will hit this recursion, count left, root dot left. So similarly it will come at this node. Okay, so for this node it will again call this root dot left. So it comes over here and it checks it hits the base case, that is now the node is null, so it will return 0 to this node. Okay, so for this node it has executed this. Now we'll come down to this. Okay, it says root dot right, so again function call hits this, return 0. So now this node has got 0 from left, 0 from right, and +1, so it returns +1 over here. Okay, it returns +1 over here. Similarly for this node, the recursion call when comes over here, it checks 0 0 from left and right, +1, so it returns 1, 1 + 1 2. Okay, 2 is the 1 from left, 1 from right, and +1, so it gets 3 from here, this node. Similarly for this, it will have 0 from left, 0 from right, and returns +1. It has 0 from left, 1 from right, returns +1, that is 2. Okay, so now this have 3 from left, 2 from right, 5, returns +1, that is 5. Similarly for this, it has 0 from left, 0 from right, returns +1. It has 0 from left, 0 from right, returns +1. It has 2, 1 from left, 1 from right, returns +1, that is 3. Okay, now it has 5 from left, 3 from right, returns +1, 5 + 3, that is 8 + 1 9. So there are 9, you can check 1 2 3 4 5 6 7 8 9. Okay, so there are total 9. So that's how I did the dry run, and you can also check the code. I did it the same way, and you can also did dry run by yourself for better understanding. Okay, now we have another important operation in a tree, that is calculating the sum of all nodes. So the code here is same as the counting the number of nodes. Okay, first I'll write the code. Okay, so again the return type would be int. I'll name the function as sum. It will take a parameter of node type, that is root. Okay, if the root would be null, so I'll return 0. Again it will calculate the sum of its nodes to its left, so root dot left. Okay, calculating the sum to its right, sum root dot right. Okay, now I'll return. So now I'll return same as the previous code which I wrote for counting nodes. Sum of left node, all the left nodes, sum of all right nodes, plus the value of current node, that is root dot val. So this will give the answer. Now I'll do a quick dry run for this. I'll make a tree. I'll make all the value as one. It would be easier to calculate, but better for understanding. Okay, so starting from the root node. Okay, I'll call this function sum node passing this root. Okay, it will not hit this base case because it is not null. It will come to this sum root dot left. It is having left, so we'll call to this. Now again recursion call comes over here with this node. It will again call root dot left. It will come to this. For this again it will call root dot left. It comes over here. Now it will hit this case that root is equal to, now the node is null. Okay, so it will return 0. It has 0 from left. Okay, now for this node has completed this execution, so it will come below. It will call root dot right. It will hit this base case. The right of this is 0. Okay, right of this is 0. So it has calculated left and right. This node has calculated left and right. Now it has got 0 from left, 0 from right, and adding root dot val, that is, it has 1, so it will return 1. Okay, Now this has completed execution. Now recursion call will come over here. So now this function has got 1 from its left. Now it will calculate right. So now it will come below on do root dot right. Now pointer will come over here. Okay, now this function will call root dot left. It will hit this base case having 0 from left, again root dot right having 0 from right, plus it will say 0 plus 0 plus root dot 12, that is plus 1. Plus 1 from where? From right. So this node has got 1 from left, 1 from right. 1 plus 1 plus root dot 12, that is 1. So 1 plus 1 2 plus 1 3, it will give 3. So this node has got 3 from its left. Now this node will call to its right, okay, and this node will call to its left. So it will come over here. Now this node will call again to its left. It will hit the base case and will got 0 from left. Again it will call this. It will get 0 from right. 0 plus 0 plus root dot 12, that is 1. So it will return 1. Okay. Now this node has got 1 from its left. It will call root dot right, that is pointer will come over here. Okay, pointer will come over here on this node. This node will call root dot right, root dot left, sorry. Now this node will again call root dot left, but now it will hit the base case, that is root is equal to null. It will return 0. 0 from left. Now it will call root dot right. There is no right, so it will return 0. 0 plus 0 plus 1, that is root dot val. It will return 1 from its left. Okay, now this node has got 1 from its left. For finding root dot right, it will call this. It will again call its left, will get 0 from left, 0 from right. 0 plus 0 plus root dot 12, that is 1. It will return 1. 1 plus 1 plus root dot 12, that is 3. Okay, 1 plus 1 2 plus it's 3, so it will return 3. Okay, for this node it has 1 from its left, 3 from its left. 3 plus 1 is 4 plus root dot 12, that is 5. So it will return 5. Now for this node it has 3 from its left, 5 from its right, that is 3 plus 5 8 plus its own value, that is 1. Answer is 9. So here you got the sum of all the nodes in a very quick and using a recursion method. This is the very same code as that of counting the nodes. So this was all from my side in this video. If you have any doubt, drop it in the comment box. Thank you.